this lightning talk is probably a lot wrong because I just finished it. No, don't finish it, wrap it. So it's about constants in C++, and I hope you can see. I will try to move so you can see. Okay, it's about const expert, const in it, and everything. So in C++, when you want some constant like D42, in past, especially in C, you did like put the expression there, and like some calculation, maybe you want to calculate something, or you can use preprocessor for that. How many people did this? Don't be shy. Only few. Okay. But you need to put like the name of the macro there. But what actually it's doing is just putting the tokens there without any checking. So if you do it like typo, put like something like this here, it's here. Bad. So if you use preprocessor, it will just put the tokens there under the name. If you like want to put something into a template non-typed argument, it must be always correctly constant evaluated, and it must be syntactically correct, but that doesn't matter here. So let's say we have constant. Finally, we have just constant, not a preprocessor, 17, and name blocks, whatever. Then we have number of records, which is 40 times per block. Can you do this?
No, we cannot.
Yes, you can. You can do this. Unless the blocks is runtime non-variable. Because if the expression is fully evaluatable in constant without any runtime value, runtime variable, it's actually, the const in it is actually constant, not immutable variable. So you can use constant as a template argument. But once it's depending on some runtime value, it's just immutable variable. So it's like static. It means many things. Okay. Yeah, and then doesn't work, obviously. So const int name equal expression. Name is constant only if expression can be constant folded, evaluated. Otherwise, it's just immutable variable. So let's say we have some function, calculate size of t by some block into some info. We have the function. Is the info constant? It's integer. Is it constant?
Yes, it's constant.
It's not, because calculate function is not constant expression, so it cannot be used in the constant expression.
But it's constant, not constant expression.
No, it's immutable variable.
Ah, yeah. Okay.
Yes.
He meant it's not constant evaluate.
Okay. So if you make the function const explorer, you can put it into constant. Now info is constant or immutable variable. It's constant evaluated. It's constant. So I want to return different type, like maybe like a block info, because I want to like put some names and maybe capacity and something else. Is info constant or immutable variable?
Depends.
Depends on the block info.
It doesn't depend. It can be constant only if it's const some type only for Boolean types and integer types, for nothing else. So if you have custom type, it cannot be. Then you calculate, put something, blah, blah, blah. And then if you want to use it as a template, you cannot, because it's not constant. So you need to make it const expert. Const int name expression, as we said before, is constant constant folding is happening only for integer types and bools. And it's optimistic. It will try, and if it fails, then it's just immutable variable. Which is funny, because that was problem with the exceptions for C++26, because they are now const expr. And you can write const int number equal std uncount exceptions. And suddenly it was constant. That was fun. Okay, const expr type name equal expression. Name is always constant. And if expression cannot be evaluated, it's a compile time failure. So you have like constant A, 42. It's implicitly const. You don't need to write it there. If it's value, it's implicitly const. You can also take reference, but it cannot be int reference. It needs to be const int reference, because it's const of the reference and not of the referee type. Const int pointer can happen also for if you have a pointer to constant things. Can you allocate? No, you cannot. You can allocate in during constant evaluation, but you need to always deallocate everything before you finish the constant evaluation. So this doesn't work, because this will tell you you have unreleased memory. You must not do that. Every time you start constant evaluation, you must release all your resources before you finish. So this doesn't work. Does this work? No. Raise your hand if you think yes. Yes, this works because C++ mandates short buffer optimization. So if the number of strings is enough, so string doesn't allocate, it's fine. But the size is different between standard libraries, so don't depend on it. Because if you put very long string, which is somewhere there, it won't work. Vector of int. Is this line fine? This one is fine because this doesn't allocate. But this one, it does. So no. So we know it must be constant evaluated correctly. You must not contain any allocation. And for C++26, I didn't put it here, you must also release all your exceptions. So it must not leak, and if you have exception pointer, you must release it too. The value of the constant expression variable is available also in runtime. You can use it in runtime. So let's say we have some calculation function which calculates median by taking a span of ints, putting them into string, using taking like middle point, and do partial sort. I'm doing terrible code, and dereferencing it. And I put median with empty initial zero list. What will happen? You will get an error here because you are dereferencing a pointer which doesn't point to anything, which is compilation time failure because constant initialization must be correct. If you put number of values, then it will work. And by the way, do you know what is it? This year's. That's year where each C++ standard was released. So no C++ 26 or 23. It's 24, 27. Well, whatever. So middle C++ is 2017. And if you do this, you have like function print middle, you take the values, you calculate the median and print online. Do you think this function is fine? Sorry. This function is not fine because constExpr can be run also in runtime. It's not needed to be run in compile time unless it's called in constant evaluated context. So this is runtime function, and if you provide empty span, it will crash. So constExpr function, they are kind of as opt-in as a bad default for C++, by the way, I think. You must have all definitions, meaning bodies of the function, visible during evaluation. Otherwise, if the body is not there, definition, you cannot constant evaluate them. They can still be run in runtime. Let's say we have constExpr large T table, we precalculate something big. In a runtime function, and we return from the table something from the table we precalculated. Is this the most optimal thing you can do? Do you see any problem with this function?
Should always be static.
Yeah, over there. If the large type is big enough and you actually are referencing it, taking reference, so beware of references, then the type is always, every time you call this function, copied on the stack. And it can be big. Every time in runtime. Maybe megabyte of table. So every time you need to mark it as a static or put it outside of the function. Otherwise, it's slow. GCC Clang, because they do that because it's required that the inline constExpr variable has address on the stack. So constExpr type name expr. Always put static or put it outside of the function to avoid the mem copy. Okay, funny trivia. This is not constExpr function. This is not runtime function. This is constExpr function, and you evaluate it in constExpr. So let's say how many times this function is called when you don't call this function. You have this function only in source code. The function precalculate. How many times it is called?
0.
So for 0, raise your hand if you think it's not called.
It's a trick question.
Yeah. Once. Okay. And if
For
I
every element in the table.
no. And if I do this, how many times this function is called in Clang?
Once.
Twice.
Once for parsing and once every time you constant evaluate function foo. Because it's a local variable and Clang doesn't cache the value, it just checks during parsing if it's correct and throw away the value away. So again, put static there and it will be fine. But if it's local variable, local constant, it's called every time you call the function foo, which means your compilation times is maybe because of this. So we have table, we precalculate something, and we can replace the constExpr with const init const, which means the precalculated thing will be constant evaluated, and it will be const. But actually, it's not exactly the same thing because it won't be constant. It will be just immutable variable. But const init itself forces the expression on the right side to be constant evaluated, which is super useful if you have like global static, which you don't want to initialize when program starts. You want to just put like value there, and you don't want to do calculation. So you can actually mutate it because it's not immutable. It's just constant initialized. Const init expression must be constant evaluated, name is constant initialized, name can be mutable, it can be used only in global scope, not in local variables, not in objects, only in global scope. Other places in standard where you can actually, in language, where you can actually do constant evaluation, trigger a new one, is in static assert when you put some expression to check it, but also for message, because you can use std format in message and you can format your error message, which then will be printed to you as you format it. Also, no except, but no except on function is also constant evaluated, but if it's no except as an expression, no except some expression inside, then it's not constant evaluated, it's non-evaluated context. Also on concepts, the right side of concept is just Boolean expression. You can put there anything you want. You can allocate during concept check if you want. Okay, we have the function median, and we have the runtime function which takes median of known values during compilation. And we have main, and we called the runtime function from it. In runtime, will this be called in runtime or during compile time? Raise hand if you think it's in runtime. And raise hand if you think it's in compile time. It will be in runtime because it's context per function. It can be in runtime, and there is no need. It will be optimized away if you enable optimization, but that's optimizer thing, not the evaluator. So if you have evaluator, it won't touch the evaluator at all. It will be just optimized inline, but it won't be calculated during compilation, but during optimization. So if you make it const eval, then suddenly this piece of code will be evaluated during compilation time because all the arguments are known at compile time. It's called immediate escalating expression. When you have const eval function with constant known arguments, it's immediate escalated into constant evaluated call. But if you put some runtime values here, what will happen? Error. It won't compile because constant evaluated function cannot depend on runtime values. And this runtime function, which is marked const expr, cannot be escalated into const eval. So const eval function has same limitation as const expr functions. Like you can use same thing as there. It won't be emitted into the binary you produce. It can be evaluated only during compilation. And evaluated code is called immediate context, and it's important for some wording in standard. Immediate escalating expression are like expression which calls the const eval function with known arguments. As I said, we have like division. We have const eval function, which is super clever function which you need to do during compile time, not runtime, because it's unsafe. And we take its pointer in const eval function and call it a function pointer. Is it fine?
No.
It's fine. You can take a function pointer of const eval function inside of const eval function.
No problem.
But if it's const expr function, you cannot do that. Because
okay.
because it was const eval function before.
Compile time pointer, yeah.
Because const expr function can be also runtime function, so it cannot take anything which is constant compile time only. But if it's const expr function and it's template, it's called immediate escalated function because if it's template, compiler will upgrade this into const eval silently. This will be const eval, even if you don't write it.
Why?
Because templates are compile evaluated.
It's same like with lambdas. Lambdas are implicitly const expr too. So we have function, and we take reflection of integer inside of concept function. Can I do that? No. Meta info is compile time value. Again, once you have compile time value, like function pointer of console function or a reflection of something, it's const eval only. So immediate escalating functions are defaulted functions. So if you have defaulted function like, let's say constructor, which is defaulted, or operator, or plus, or operator plus, and if they would like do operation which touch const eval only resource like type or whatever, they will be upgraded into const eval. Lambdas are implicitly const expr, but if you do something which is there even without typing const expr, which is const eval only, they will become const eval only. Also, if you have templated const expr function, that can happen too. So yeah, so I have a function which returns reflection, and it's called make type. I have this undefined type magic pair, and I create an aggregate of the magic. I'm defining the aggregate under the name magic pair, and it will have two members, integer x and integer y. It's a console function. This is like reflection. Can I call this function multiple times? How many people, like raise your hand if you think I can call this function multiple times? No, because, sorry, you cannot, because once you call it, you're defining the type again, and if you already define it, you will get error that is already defined type. No, not ODR, error. It's because it's already defined and it's inside of the one translation unit and it's known. So you have function, you call it somehow inside the reification, and you can give it a different name, and you have like certain two types, but that's not nice because maybe you have the struct magic pair inside of the function, so it's not like available the name, but maybe it's outside. I think people used was like lambda, which is immediately called, and it will define the type for you. But that's ugly. So 26 also has this const eval blocks, which can be anywhere, and it's kind of like static assert with immediately called lambdas. So if you define new type or something based on like name, or you do some reflection, because reflection has side effects on your program, then you can just use const eval block. And yeah, and that's all. Thank you. Sorry.